You know how we have the vertical line test and the horizontal line test, and we can learn things from those tests? So I'm gonna introduce a new test to you called the lead coefficient test. This is gonna take us 3 days. It's gonna take us, you can see by the schedule up there, 2-3A, 2-3B, and 2-3C. So we're just introing it today. We're not gonna learn everything about it, but we're just gonna get a peek at it. Okay, and so first you need to know what a lead coefficient is. So in a problem that's in order, ax to the n is what's called the lead coefficient, as long as the problem is in order. If the next number comes right after it, what do you know about the x power for the one that's right after that? Assuming that these are in order. It's going to go down, right? It's going to be n minus 1. It's going to be smaller. And then the next one would be cx, and that would go down again. And then dx, and that one would go down again. And it just keeps going and going and going. But the front part is called the lead coefficient. And that can be very valuable when you do a test on it to helping you understand a question. All right, knowing what that is going to be is going to help you categorize the function that you're doing. So there are different categories. The different categories we've talked about before, they are quadratic. Quadratic are aka parabola. After a quadratic comes a cubic. After a cubic comes a quartic. After quartic comes quintic. These are all in your calculator built in as regressions. And the power just keeps going up. So parabolas are power 2. So they're going to look like ax squared. Cubics are power 3. So they're going to look at ax cubed. Quartics are power 4. Quintics are power 5. And then there are official names for all of the other ones, power 6, power 7, power 8. But I'm not going to make you be responsible for all those extra names. Just I want you to know those first couple. A power is also called a degree. And so the degree is also the same thing as the power. So first of all, the lead coefficient test can help you categorize what kind of function you're looking at. And so let's learn about these shapes. You already know about quadratic. Okay, quadratics either are right side up or upside down. They're either reflected or basic or normal. And you already know about cubics too. Cubics, basic plain cubics, just look like this. Those aren't very interesting. But more interesting cubics look like this and have a little bit more of a dip and a swerve to them there. So you have a maximum and a minimum peak, a little high-low action going on. But those can be reflected also. And so then they would look like this. So those are called cubics. One thing that's helpful to know is if you know the degree, if you know the power, then the number of dips it will have is 1 less. So a power is degree 2, so it only has 1 dip or 1 max or min. A cubic is degree 3, so it will have 2. It'll have 2 dips, or a max and a min. So what does that mean about a quartic? It's going to have 3, and that tends to look more like a W. So a just normal one would look like this. But they can be elongated and changed around, like the first one could be shorter than the second one, so the second one could dip farther down. So it doesn't always have to be perfectly even, perfectly symmetric. And if it's upside down, You know, one of them could be, you know, a higher maximum than the other, but there's still like 3 turns. Think of it like a turn. A quadratic is degree 2, but it turns once. A cubic is degree 3, but it turns twice. A quartic is degree 4, but it turns 3 times. So a quintic is degree 5, which means it has to turn 4 times. So watch me draw the turns, right? So a quintic will come up, and I got to count my turn. Turn 1, turn 2, turn 3, turn 4, right? 1, 2, 3. Got 4 turns in there. Here's turn 1, here's turn 2, here's turn 3, here turns 4. Again, same thing. The first turn doesn't have to be the lowest turn. It could be like this. That would also count as a quintic. And it has 4 turns. 1, 2, 3, 4. Or it could be reflected upside down. It could go turn 1, turn 2, turn 3, turn 4, and go that way. So the lead coefficient test helps you to know the degree so that you know the shape, and it helps you to know whether or not it's going to be a reflection or not. So here's the actual test. We call it the LCT, AX to the N. N tells you the degree, which connects you to the shape, and it will have n minus 1 turns in it, 1 less. What if you just have plane X? What's the degree on plane X? Yeah, what's the degree? 1. So how many turns will it have?
0.
Which is why it makes it a straight line. Okay, so that still works. And then A tells you the reflection, n minus 1. I'll make that a little clearer for you. And that means 1 less. So A tells you the reflection or the stretch. And that is the lead coefficient test. It's what you learn just by looking at the lead term, as long as the terms are in order. Okay, they always try and sneak one in there where the terms are out of order, and then you just look at the first one and you don't realize there's actually something higher buried farther back in the question. So here's the kind of things that you might be asked about. Y equals negative 2x to the 7th plus 4x cubed minus 1. Describe the behavior of the 2 ends. And by the 2 ends, I mean the 2 arrows at the end of each end of the graph. So I want to know, what is the left end doing and what is the right end doing? Well, this category is a category 7, which means it has how many turns? Has 6 turns. Okay. Being a category 7, it's going to look like the cubic and the quintic. It's in that odd family. Okay, the odd ones tend to look the same or similar. They start and then you start counting their turns. And so you kind of picture this in your head. You're like, okay, I'm going to be going, okay, 1 turn, 2 turns, 3 turns, 4 turns, 5 turns, 6 turns, 7 turns. Except it's got a negative. So then it's just going to be upside down. Now, do you have to make this a perfect graph? And the answer is absolutely not. All I need to know from you, then it's going to go 1 turn, 2 turns, 3 turns, 4 turns, 5 turns, 6 turns, 7 turns. All I want to know is what the ends are doing. So the left side of the graph is pointing in what direction? The left end of this snake thing. It's pointing up, right? And so we say up, or we can say increasing. You may use either of those words and I will understand what you mean. Increasing is the better word to use. And what's the right end doing? It's decreasing. So as an intro to the lead coefficient test, that's all you need to know so far. We're going to learn about how to make the bounces really accurate in the middle, but right now we're just talking about what the ends are doing. Okay, last example. Y equals 5x to the 5th minus 3x to the 8th. Why? Okay, so yes, tricky because I gave it to you in the wrong order. And so you want to make sure to put it in the right order, so switch it around. So negative 3x to the 8 plus 5x to the 5th. Now this is an even. It's an 8, which means it's going to look like the quartic. It's going to look like the even ones, like a degree 2, a degree 4, a degree 6. So it's going to kind of look like a parabola to start, except that it's got a negative. It's going to be upside down. So it's going to look like, okay, 1, 2, 3, 4, 5, 6, 7, 7. So what do the ends do? They're both going down because of the reflection. And so the left end is decreasing, and the right end is decreasing. All even category families will have their arrows going in the same direction, because if you have an odd number of curves, then the ends are always going to end up pointing in the same direction for an even family. For an odd family, they'll always end up pointing in the opposite direction. Odd, opposite, even, equal. Okay, that helps you work it out. You just got to know about the reflection.